Friends, welcome to the class. Today we'll discuss about relationship between zeros and coefficient of a polynomial. For linear polynomial fx equals to ax plus b, if k is the zero of the polynomial, then k equals to minus b by a, that means k equals to minus a constant term by coefficient of x. Let's see an example. The zero of px equal to 2x minus 3 is 3. Justify. Given polynomial is px equals to 2x minus 3 and 3 is the zero of the polynomial. So comparing with the standard form, we get a equals to 2 and b equals to minus 6. So putting p of 3 equals to 2 into 3 minus 6, which is nothing but 6 minus 6 is which is equals to 0. Following the above relation, 0 of the polynomial is minus b by a, which is nothing but minus of minus 6 whole divided by 2, or it is 6 by 2, which is equals to 3. So 0 of px is 3 is justified. That means, so we can say k equals to minus b by a. This relation holds good. For a quadratic polynomial fx equals to ax square plus bx plus c, if alpha and beta are the zeros of the polynomial, then sum of the zeros, that is alpha plus beta, equals to minus b by a, which is equals to minus of coefficient of x by coefficient of x square, and product of zeros, that means alpha into beta, equals to c by a, which is equals to constant term by coefficient of x square. Let's see an example. The zero of polynomial px equals to x square minus x minus 12 are 4 and minus 3. Justify. The given polynomial is px equals to x square minus x minus 12 and the zeros are 4 and minus 3. Comparing the given polynomial px equals to x square minus x minus 12 in the standard form, that means x square plus bx plus c, we get a equals to 1, b equals to minus 1 and c equals to minus 12. Here, sum of the zeros, that means alpha plus beta, equals to 4 plus minus 3, which is equals to 1, and the product of the zeros is alpha beta, that is 4 into minus 3, which is equals to minus 12. Now, following the above relation, we get alpha plus beta is nothing but minus b by a, which is nothing but minus of minus 1 whole divided by 1, which is 1. And alpha beta equals to c by a, that is minus 12 whole divided by 1, or it is equals to minus 12. So in both the cases, we are getting the same result. Hence, the above relation, the sum of the coefficient alpha plus beta equals to minus b by a, and the product of the zeros equals to alpha beta equals to c by a. What's good? Now, for a cubic polynomial fx equals to ax cube plus bx square plus cx plus d, if alpha, beta and gamma are the zeros of the polynomial, then sum of the zeros, that means alpha plus beta plus gamma, equals to minus b by a, which is nothing but minus of coefficient of x square by coefficient of x cube. Product of the zeros, that is alpha into beta into gamma, equals to minus d by a, which is nothing but minus of constant term by coefficient of x cube, and alpha beta plus beta gamma plus alpha gamma equal to c by a, which is nothing but coefficient of x by coefficient of x cube. Let's see some examples. If zeros alpha and beta of a polynomial x square minus 7x plus k are such that alpha minus beta equals to 1, find the value of k. Here the given polynomial is px equals to x square minus 7x plus k, and comparing with the standard form, that is ax square plus bx plus c, we get a equals to 1, b equals to minus 7 and c equals to k. We know sum of the zeros, that is alpha plus beta equals to minus b by a, which is nothing but minus 7 minus of minus 7 by 1, which is equal to 7. So we got alpha plus beta equals to 7, and already we are given with the data alpha minus beta equals to 1. So on solving the above two equation, we get alpha equals to 4 and beta equals to 3. So the zeros of the given polynomial px equals to x square minus 7x plus k are 4 and minus 3 is the answer. Now p of 4 equals to 0 and p of minus 3 equals to 0. Let's see p of 4 equals to 0. So we get 4 square minus 7 into 4 plus k equals to 0, or on solving we get k equals to 12. Thus the value of k is 12. If alpha and beta are the zeros of 4x square plus 3x plus 7, find the value of 1 by alpha plus 1 by beta. Here the given polynomial px equals to 4x square plus 3x plus 7. So when comparing with the standard form, we get a equals to 4 and b equals to 3 and c equals to 7. We know alpha plus beta equals to minus b by a and alpha beta equals to c by a. So alpha plus beta equals to minus 3 by 4 and alpha beta equals to 7 by 4. Now 1 by alpha plus 1 by beta is, if we take alpha and beta to be the LCM, it is equals to alpha plus beta divided by alpha beta. Now putting the value of alpha plus beta and alpha beta in the respective places, we get 1 by alpha plus 1 by beta equals to minus 3 by 4 by 7 by 4, or it is equals to minus 3 by 7 is the answer. And the zeros of the polynomial fx equals to x cubed minus 5x square minus 2x plus 24 if the product of any two zeros is 12. So the given polynomial is fx equals to x cubed minus 5x square minus 2x plus 24. On comparing with the standard form, that is ax cubed plus bx square plus cx plus d, we get a equals to 1, b equals to minus 5, c equals to minus 2 and d equals to 24. Let alpha, beta and gamma are the zeros of the given polynomial fx, and product of any two zeros, that is alpha and beta, alpha beta equals to 12. We know alpha plus beta plus gamma equals to minus b by a, alpha beta plus beta gamma plus alpha gamma equals to c by a, and alpha into beta into gamma equals to minus d by a. Or we can write it as alpha plus beta plus gamma equals to minus of 5 minus of minus 5 by 1, or it is equals to 5. Let this is the first equation. Alpha beta plus beta gamma plus alpha gamma equals to c by a, which is nothing but minus 2 by 1, or it is minus 2. Let this is equation 2. And alpha into beta into gamma, it's minus d by a, which is nothing but minus 24. Let this is third equation. Now putting the value of alpha beta equals to 12 in equation 3, we get 12 gamma equals to minus 24, or gamma equals to minus 24 by 12, which is equal to minus 3. Now putting the value of gamma in equation 1, we get alpha plus beta minus 2 equals to 5, or alpha plus beta equals to 2 plus 5, which is equals to 7. Or you can write it as alpha equals to 7 minus beta. Let this is the fourth equation. Now since alpha beta equals to 12, we can write 7 in minus beta into beta equals to 12. We're replacing the value of, we're putting the value of alpha in the given equation, or we're getting it as 7 beta minus beta square equals to 12, or we can write it as beta square minus 7 beta equals to minus 12, or beta square minus 7 beta plus 12 equals to 0. By taking middle term factorization, it is beta minus 4, 4 into beta minus 3 equals to 0, or beta equals to 4, or beta equals to 3. Now putting the value of beta in equation 4, we get when beta equals to 4, alpha equals to 7 minus 4, which is equals to 3, and when beta equals to 3, alpha is equals to 7 minus 3 equals to 4. Hence the zeros of the polynomial are 3, 4 and minus 2. Two zeros of a cubic polynomial ax cubed plus 3x square minus bx minus 6 are minus 1 and 2. Find the third zero and the value of a and b. Let fx equals to ax cube minus plus 3x square minus bx minus 6. Since minus 1 and minus 2 are the zeros of fx, we have f of minus 1 equals to 0 and f of minus 2 equals to 0. Now putting the value of x as minus 1, we get f of minus 1 is e into minus 1 whole cube plus 3 into minus 1 whole square minus b into minus 1 minus 6, or we are getting minus a plus b equals to 3. Then this is first equation, and f of minus 2 is a into minus 2 whole cube plus 3 into minus 2 whole square minus b into minus 2 minus 6 equals to 0, or it is nothing but minus 4a plus b equals to minus 3. Let this is second equation. By solving equation 1 and equation 2, we get a equals to 2 and b equals to 5. Now let gamma be the third zero of the given polynomial. We know that alpha plus beta plus gamma, alpha into beta into gamma equals to minus d by a. Putting the respective values of alpha beta, we get minus 1 into minus 2 into gamma equals to minus of minus 6 by 2, or 2 gamma equals to 3, or gamma equals to 3 by 2. Thus a equals to 2, b equals to 5, and the third zero is minus 3 by 2 is the answer. Friends, here is a few examples, few questions. The more and more questions you practice, the easier it becomes and the more you like it. So friends, practice more and more such question, and in case you come across difficult question, do share your question with me. It will be a pleasure for me if I can help you out in solving your question, in solving your doubts. This one for today's class. Thank you.